Hey everyone, today I want to take you behind the scenes of something that I've been building recently, a side project of mine called My Test Compass. It's an AI assistant designed to help frontline lab technicians. A few months ago, I spent the morning shadowing our mobile lab teams. Now, picture this, it's 6 a.m., they are carrying heavy bags with collection kits, juggling dozens of patient samples, and at every stop, they have to remember which tube to use, how much of it to fill, what temperature to store it at, and how fast it needs to reach the lab. Now, the official manual is hundreds of pages long, and the information is scattered across. So, in reality, they rely on memory, handwritten notes, or quick calls to supervisor colleagues. That's not just inefficient, it adds to stress, need for manual workarounds, increased risk of collection errors, and can even lead to longer turnaround times if the sample has to be redrawn. Now, that's not only frustrating for patients, but it is also driving up operational costs. And that's when I realized the problem isn't access to information, it's access to answers. They did not need another document. Rather, what they needed was an intelligent assistant who could think like a senior colleague standing right next to them, someone who never forgets protocol. So here is how it works. Instead of manually searching in PDFs or calling for help, the technician sends a message on the Telegram channel. I've already uploaded the official knowledge sources in this Google Drive folder. And when a technician sends a message asking for storage requirements about a particular test, the agent would go and retrieve information from one of these data sources. In this case, it has responded. The vitamin D test has to be stored and shipped refrigerated, which is exactly what is also present in the test directory here. Let's say I ask a follow-up question on the number of tubes that are needed for this test. Now, I'm not specifying it to be vitamin D. It already knows that we're talking about vitamin D, and it has responded that we need one tube, which is a SST gold top, for this test. So for this question, it is going to retrieve that information from a structured database, in this case, the lab simulation one, and it has correctly identified that we need one SST gold tube for this test. And if somebody asks something irrelevant, like what is the price for the vitamin D test? Now, there is no pricing information in any of the uploaded documentation, so it will inform the user that it couldn't find what they were looking for. Now, this keeps the response accurate and trustworthy. There's no hallucination or guesswork. And it is also robust enough to handle questions that need to get information from multiple databases and then consolidate the response in a message. So in this case, I am asking it for number of tubes that would be retrieved from an SQL tabular database here. And then the draw order would be retrieved from a textual data source. So as you can see, it has responded with a lavender tube for CBC and a light blue tube for D timer. And the draw order is light blue tube first, followed by the lavender tube, which is exactly what the order of draw in this document also specifies. Light blue first, followed by lavender. So behind the scenes, it's combining structured data reasoning and semantic retrieval from Google Docs or PDFs seamlessly. Now let me walk you through how I built it. I've used n8n as the orchestration layer. The flow starts with a messaging app trigger. This could be Microsoft Teams, Telegram, Slack, WhatsApp, or any other app that integrates with n8n. For this demo, I've used Telegram because it's quick to set up and easy to visualize. But ideally, the assistant should live inside a tool that the technicians already use every day. The goal here is not to make them learn something new, it's to bring intelligence into their existing workflow. Now, each message received in the Telegram group is routed to the AI agent node powered by Google Gemini for reasoning. And here is where the architecture gets interesting. I've combined two retrieval approaches for maximum accuracy. So I'm using a Pinecone vector store for semantic search across text-based documents like PDFs and Google documents. I chose Pinecone because it's fairly good at handling large-scale semantic search with low latency and high precision. It makes it ideal for a healthcare use case where accuracy and speed both matter. And then I'm using a Superbase PostgreSQL database for structured data. Now this data is test to tube mappings, calculating number of tubes required. Now the agent intelligently decides which one to use to answer a question. For procedural and descriptive questions, it will call the vector store, and for tabular or numeric questions, it will create an SQL query and get data from the SQL tables. So the agent has a system prompt which determines how it operates. It has a role, it has an objective. I have specified what knowledge sources are available for it to use and how it should use the tools that are there at its disposal. So for text-based queries, use the vector store. For tabular or numeric data, generate an SQL query and get information from the SQL table. And then examples for each of those. I've also instructed it to follow a particular decision flow, first by identifying what kind of question it is, and if it is unsure, what should the fallback strategy be. It also has clear instructions on what to say when it does not find responses. It has a tone, an output style, and then I've also given it a few examples of how an average conversation plays out between the user and the agent. I've also added a Postgre chat node, which basically maintains the context across multiple conversations. And then what I've also done is I've added another workflow, which is an auto ingestion pipeline that monitors the Google Drive folder. Now, every time a document is added or updated, it automatically reindexes the Pinecone vector store and the Superbase tables. That way, it ensures that the system is always current with the latest lab protocols. Now, in case of changes, all the user has to do is upload the new protocol and the system will take care of the rest. So this architecture is designed for scalable retrieval from curated knowledge base of verified content. It has a high degree of confidence in its responses, so no hallucination or guesswork, and it ensures every answer is grounded in trusted data. It's also low maintenance and is easily reusable across other enterprise workflows. For me, the project turned into a practical study in problem discovery and solution design, starting with observing real users, identifying where friction lives, and then using technology to thoughtfully remove it. By connecting verified lab data and modern AI tools, we've built a system that reduces mental load, improves sample accuracy, and helps new staff get up to speed faster. Thanks for watching.